Okay, we are now going to continue with a discussion of the concept of transfer. First, we are going to make a distinction between two types of transfer, and then we will proceed by discussing the issue of conceptual change. First, we focus on two types of transfer. As it is already shown here, we make a distinction between low road transfer and high road transfer, terms originally developed by Salomon and Perkins back in the 1980s. In order to understand the difference, it's easy to have a look at the so-called learning triangle. What you see here is that you can go from one concrete experience to another concrete experience, either by choosing the path along the base of the triangle, that's the low road transfer path, or you take the route along the vertex of the triangle, and that's the high road transfer route. So low road means actually what we already have been discussing, practicing in order to be able to apply what you have learned in the learning environment in any application environment you choose. So applying knowledge and particularly skills requires a lot of practice. So that is basically the low road transfer route. The high road transfer route is more complex because in this case, and now we are talking again about deep level learning, you develop let's say models or schemata, as it is called here in this figure, or strategies, which help you to let's say make the skill you have or the strategy you have learned detached from the learning environment in order to apply it in a variety of application situations. So developing these kinds of models or strategies also fosters transfer. Think of devising a plan to write a paper. You can develop such a plan after you have done your first paper or your first couple of papers. And then you can think of, let's say, how did I actually address this task? First I collected a lot of information, of course. Then I made a sort of, a plan. I composed a sort of outline of the paper. Then I wrote down the paper, and then I sent it out for feedback, and then I revised the paper. So these stages of, let's say, collection of information, composition of an outline, writing and revising, well, these are the 4 stages I usually go through when I write a paper. Now, when I have to write a new paper, I can think of these 4 stages, and I can make a plan, allocating time for each of the 4 stages in order to complete the task. Okay, so that's an example of developing a strategy which helps you to apply what you've learned in one situation to other situations. Okay, we are now going to discuss in more detail the 2 types of transfer. First, low road transfer. Back in the 19th century, teachers thought that teaching subjects like Latin and logic and mathematics helped children and students to think in a more rational, in a more sound way, in all kinds of application situations. So these formal disciplines like Latin and logic were supposed to provide a sort of transfer effect in all kinds of everyday situations where you have to reason. Now, unfortunately, this turned out not to be true. So Thorndike analyzed this potential effect, the doctrine of formal discipline, and came to the conclusion that it does not hold. It's not true, in fact. So therefore, he developed an alternative let's say, a view, a theory, and what he called the theory of identical elements. So his idea is that in order to be able to transfer a learned skill from a learning environment to an application environment, there need to be identical elements, similarities between the learning environment and the application environment. And these similarities are required, in so to speak, to make transfer possible. Now, you can discuss, of course, what kind of elements did Thorndike think of. Were they part of the task, for instance, or were they part of the environment, the temperature, or perhaps the color of the walls, or whatever? So there may be some sort of abstraction in the elements we are thinking of. Singley and Anderson, they did research on this subject, and they arrived at a sort of view that you may be able to write a computer program or let's say a representation of the task you're carrying out and the steps you have to take in the task, and this program, so to speak, determines the elements which have to be identical in the learning environment and the application environment. Singley and Anderson did some experiments with secretaries who worked with various text editing programs like Microsoft Word or LibreOffice if you're working in a Linux environment. And they trained these secretaries to do a particular task in, let's say, one environment. So let's take Microsoft Word, and then they had to learn to apply the same task in a new environment, let's say LibreOffice or another text editing program. And then they measured how much time it took the secretaries to learn the task in a new environment compared with the original task. And when the two text editing programs were very similar, it was quite easy to learn the task in a new environment compared with a situation where the two text editing programs are completely different, and you have to do completely different operations in order to complete the task. So the amount of similarity between the two text editing programs determined the amount of transfer, in fact. And that's how Singley and Anderson, let's say, operationalized the idea of what identical elements are. Okay, then we can make a distinction between near transfer and far transfer. You can imagine again that the learning environment and the test and the application environments are quite similar, and that it takes not much effort to, let's say, generalize the skill you have learned in an application environment and apply it there. So then we speak of near transfer. When you play a particular piece on the piano at home, and then perhaps in the room of your teacher, maybe the distance between these two environments is small, and it is quite easy to apply the skill you've learned playing this particular piece in the room of the teacher. Then we have near transfer. But if you have to play it, on the stage of the Concertgebouw or any other theater, then the distance might be quite large, and then we talk about far transfer. So you can also think of problems, mathematical problems, where you have learned a particular, let's say, strategy to solve these problems. Now you can imagine that you offer all kinds of problems, and that some problems are more complex or more elaborate, and therefore it requires a lot of effort to apply the particular solution methods in that environment, and then we talk about far transfer. So it's basically related to the idea of identical elements. If there are many identical elements, then we have near transfer. If there are few identical elements, we talk about far transfer. Okay, now we are going to move to the high road transfer issue. What we see here are three different routes in order to climb, this vertex of the learning triangle, and develop, let's say, abstract knowledge, which helps you to apply your skill or strategy in a new environment, in a new concrete environment. Now, abstraction, of course, is the first step. So building these schemata is basically the way in order to arrive at high road transfer, as I already explained. I gave the example of the strategy to write a paper. You can also think of planning strategies, planning projects, or strategies to carry out various tasks in a particular order. So these strategies, they are developed consciously, deliberately, purposefully, and they help you to apply what you've learned in one situation in a new situation, in an application environment. Another strategy is not so much developing, transfer strategy is not so much developing a model or a strategy, but it is focused on, let's say, detaching your strategy from the environment in which you have learned, decontextualization. There's a very interesting series of studies done originally by Karl Duncker after the Second World War, and then again with by Gig and Holyoake, who used the problem Duncker developed, the so-called tumor problem. I'll show you the problem. Imagine that you have a tumor in your stomach, and this tumor has to be eradicated by applying X-rays. Now, the problem with these X-rays is that they kill all tissue along the way, on their path, so to speak. So, if you have a tumor embedded in healthy tissue and you apply an X-ray, then not only the tumor will be killed, but also the healthy tissue around the tumor. And that's not what we want. We want only the tumor to be killed and not the healthy stomach which surrounds the tumor. So that is basically the tumor problem by Duncker, and the question is, how are we going to solve this problem? There are solutions for it. Now, if you ask participants to solve the problem, they will have a very hard time finding the solution. But there is another way to help them to solve the problem, and that is by providing them another task. The task is called by Gig and Holyoake the fortress task. Imagine that you have a castle on the top, a fortress on the top of a hill, and there are various small paths leading to the top. Now, there's an army at the bottom of the hill, and the army is supposed to capture the castle. But the army is not able to choose a particular path because it simply is too small. It doesn't allow for all the soldiers to take it. So, what does the general do solving this particular problem? Now, the general knows that there are various ways up to the castle, and the general distributes his army over the various paths, and the soldiers take these various paths, and then they meet at the top of the hill, and then they capture the castle. So you can make a picture of this strategy, so to speak. So the general approaches the castle through various paths, which are by themselves small, but they allow all soldiers to go up because they take these various different paths and meet at the top of the hill. Now, if you offer this problem to participants, they will be able to solve it. And if you, after this problem, offer them the tumor problem, then they more easily come up with solutions, and these solutions all use not one X-ray apparatus, but 2 or 3 X-ray apparatus which direct their X-rays from various angles towards the tumor. So the tumor will be attacked from various ways, let's say 2 or 3 ways, and the X-rays meet, so to speak, in the tumor, where they are able to kill the tumor without damaging the healthy tissue on the way to the tumor. So the X-rays are weak X-rays, unable to kill tissue unless they are combined, and then their added, let's say, power will indeed kill the tissue, which is the tumor. Okay, so that is a solution for the tumor problem. There are other solutions, but this is one of the solutions. And the interesting thing is that when you offer participants first the fortress problem and then the tumor problem, you will see that many more participants are able to solve the tumor problem, particularly when the experimenter instructs the participants to use the fortress problem and the solution of the fortress problem to solve the tumor problem. So when they are actually also primed to do that, they are indeed successful in solving the tumor problem. Now, this priming effect is in fact the decontextualization effect we were talking about, because the instruction to use the solution of the fortress problem actually entails that students decontextualize that solution, take it from the fortress problem and apply it in the tumor problem. And then we arrive at high road transfer. So the solution strategy is learned in one situation and is applied in a new situation, the tumor problem. And the instruction to decontextualize helps students to bridge the two problems, so to speak. Okay, then there is the third way to foster high road transfer, and that is promoting access to knowledge. That is an approach which was developed by Prawat in 1989, and he suggested that increasing the coherence of a particular body of knowledge, for instance, your knowledge about a particular phenomenon and the explanation and the theories and the concepts around this phenomenon, that helps you to develop, to apply this knowledge. For instance, we are now talking about transfer. We make a distinction between two types of transfer. And I offered you the image of the learning triangle. Now, this image might serve as a sort of key idea, as a sort of organizing idea, which helps you to remember that there are two types of transfer, low road and high road, because there are two ways in which in this learning triangle you go from one base point to another base point, to the left corner and the right corner, the left concrete experience and the right concrete experience. So the learning triangle is a key idea, is an organizing principle. It creates coherence in these facts and concepts and theories, and it helps you to apply your knowledge in a new situation in which, for instance, somebody is asking, how do we help children to what they have learned in the learning situation to apply that in a new situation, in an application situation. Okay, so this is a way to promote access to knowledge. So you actually organize the knowledge in a better way, therefore it's better accessible. You could also, of course, ask students actively to develop these ideas, to inductively create this abstract knowledge, and also this instruction to verbalize, to write down what they have done in a particular learning environment may help them to apply what they have learned in application situations. So these are all ways to promote access to knowledge and help students to arrive at high road transfer. Okay, now we have discussed two types of transfer, and we are able, I think, to proceed to the next unit in this module.